All right, here we go. Unit 6, Lesson 5. We're going to learn about some properties of logarithms. And so we're going to start off by just kind of reviewing a few of these logs and seeing if we can notice what this property is going to be on our own. Remember, when you see log, when you see this log right here, what you want to think is what power? Right? It's basically asking what power of 2 is 8, and that would give us 3 because 2 to the third is 8. The log base 2 of 4, what power of 2 is 4, is 2. And then here's kind of an interesting one I've put together. What about the log of 8 times 4? Well, 8 times 4, that's 32, and 2 to the fifth is 32, so this has to be 5 here. Okay, let's keep going. You may see the pattern already. The log base 3 of 9 would be 2 because 3 squared is 9. The log base 3 of 27 would be 3 because 3 to the third is 27. Well, what if we multiply these two things together? Well, 9 times 27, that's 243. And, maybe you don't know this, but you kind of sit there with a calculator for a second. If you keep doing multiply by 3, it goes 3, 9, 27, 81, 243. So this is also 3 to the fifth power here. Let's do one last one. If we have the log base 2 of 16, that would be 4. The log base 2 of 4, that would be 2. And the log of 16 times 4, well, that's 64. And, okay, how many 2's does it take to make 64? 2, 4, 8, 16, 32, 64. That's 6. And if you look at this pattern here, right, notice what I was doing. I was taking the inside, right, the argument of these logs, and I was taking the arguments from the previous two, and I was multiplying them. And what happened was, to get this result at the end, we just add the results of the previous two. And so this is our first log property. If you have two logs that are in the same base, right? So it is important that, like, I did this with the log base 2's together, the log base 3's together, the log base 2's together. If you have the log of x plus the log of y, you get the log of x times y. And I think the easiest one to consider why this is true is probably this one, right? Just think about what's going on here. If you have the log base 2 of 8, which is 3, and the log base 2 of 2, which is 1. Log base 2 of 2 is 1, log base 2 of 8 is 3. To increase this log, right, just if you think to yourself, what do I have to increase this 8 by to get the final log to go up by 1? Well, that has to become 16, because it's not until we fully doubled that we go up by 1. And so when you look at it that way, you can see why if we add two logs together, it's like what we can do is we can multiply the interior parts together. And so here's two examples of this, right? If we have the log base 2 of 8 and plus the log base 2 of 16, right? I've got the log base 2 of 8 times 16, or the log base 2 of 128. Now maybe I don't know, right? Maybe I don't know what power of 2 is 128. But if I know that the log base 2 of 8 is 3 and the log base 2 of 16 is 4, I can get that the log base 2 of 128 is 7, and it in fact is. We can do this with any kind of interior or argument of the log. The log of x plus 2 plus the log base 2 of x minus 2 is the same thing as the log base 2 of x plus 2 times x minus 2, which, of course, is the difference of two squares. This is x squared. In the middle, you're going to have a plus 2x and a minus 2x that cancel out. So this will just be the log base 2 of x squared minus 4, for whatever those numbers are. The second log property, right, is that the reverse is also true. if the log base 3 of 81 is 4, the log base 3 of 9 is 2, if we divide these two things, the log base 2 of, sorry, I should say log base 3, the log base 3 of 27, right? 81 divided by 3 is 27. What we're going to have here is 3, right? Because 3 to the third is 27. I was like, why is that? I was like, why is that not adding up? And that's not adding up because I made this one a 9, but that should have been a 3. So now we have the log base 3 of 3 is 1. So now you can see we have 4 minus 3 to get 1. So sorry, 4 minus 1 to get 3. So we have our second log property here, and that is if you have two logs that are subtracting each other and they have the same base, we divide their interior components to get log of x minus y, right? And so actually this is that example right here. And so here's just like one more example of what you might see on the Delta Math today. We've got, we're going to pretend this is A, this is B. If they are being subtracted, this right here will be the log of A over B. And so what we need to do is we need to divide, right? We need to divide x squared plus 6x plus 8, this is a tricky one, divide it by x plus 2. And it turns out that if we factor, this is going to be x plus 4 times x plus 2 in the numerator divided by x plus 2. So the x plus 2's will cancel. What will be left with here is x plus 4. So the key points to remember when you do the Delta Math today, the two things that we're learning today, if you have, and again, it all has to be the same base, if you have the log of A plus the log of B, this is equal to the log of A plus B. If you have the log of A minus the log of B, this is equivalent to the log of A minus B. Those are the two things you want to work through today on the Delta Math.